Hello and welcome back. Today we'll be continuing the topic of last week's video. This is a practice question on the topic of expectation. Let's get started. Question 12. The random variable x has the probability density function on the interval 0 to 1 of f of x is equal to n x to the n minus 1, where 0 is less than or equal to x less than or equal to 1, and 0 elsewhere, where n is an integer greater than 1. Let mu equal e of x. Find an expression for mu in terms of n and show that the variance sigma squared of x is given by sigma squared is equal to n over n plus 1 all squared n plus 2. Part 2. In the case n is equal to 2, show, without using decimal approximations, that the interquartile range is less than 2 sigma. Part 3. Write down the first three terms and the k plus 1th term, where 0 is less than or equal to k is less than or equal to n, of the binomial expression of 1 plus x to the n in ascending powers of x. By setting x is equal to 1 over n, show that mu is less than the median and greater than the lower quartile. Note, you may assume that 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, etc. is less than 4. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started. Firstly, we'll use the formula for the mean and say that mu is equal to the integral between 0 and 1 of x n of x to the n minus 1 with respect to x, which is equal to the integral between 0 and 1 of n x to the n with respect to x. This is equal to n over n plus 1. Similarly, e of x squared is equal to n over n plus 2. Therefore, the variance is equal to n over n plus 2, take away the square of n over n minus 1. This is equal to n over n plus 1 all squared n plus 2, as required. Now, let's move on to part 2. Setting n to be equal to 2, we have that the variance is 1 over 18, and therefore the standard deviation is root 2 over 6, meaning that twice that is root 2 over 3. On the right here, we can calculate the quartiles, and we will find that on the right, we can calculate the quartiles, and we'll find that q1 to the n is equal to 1 quarter, and therefore q1 is equal to 1 half. Similarly, q3 is equal to root 3 over 2. q3 take away q1 is therefore root 3 over 2 take away 1 half, which is less than root 2 over 3, which is equal to 2 sigma, as required. Now we can move on to part 3. Firstly, we'll write down 1 plus x all to the n. The first three terms are 1, nx, and n minus 1 all over 2 of x squared, and the k minus 1th term is n factorial over n minus k factorial multiplied by x to the k. Now we'll calculate the integral between 0 and q of f of x with respect to x. This is equal to q to the n. We'll now calculate the lower quartile and the median. The lower quartile is the nth root of 1 quarter, and the median is the nth root of 1 half. Now we can calculate 1 over mu all to the n, and this is equal to 1 plus 1 over n all to the n, which is greater than 1 plus n multiplied by 1 over n, which is equal to 2. Therefore, mu is lower than the second quartile, or the median, as required. We can calculate 1 over mu to the n again, and this is less than 1 plus n 1 over n plus n squared over 2 factorial, 1 over n all squared, etc., which is equal to 1 plus 1 factorial plus 2 factorial plus 3 factorial, etc., and this is less than 4, as given in the question. Therefore, mu is greater than Q1, as required. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.